right? You know, this is example 6, and it's also a very standard kind of example that we see when they're introducing limits, because it makes a particular point, right? The absolute value of x divided by x. Okay? If you look at it in a graph, and I've already loaded it for the calculator. File, open, 6, right there. Okay. If you look at the graph, notice here's the graph. It's -1 until it gets to the y-axis, and then it's 1. Well, again, look at this function, right? Because it's got an absolute value in the numerator, but it does not in the denominator, right? The numerator is always going to be positive. The denominator will be negative when x is less than 0. So when x is less than 0, this is a positive over a negative, -1. When x is greater than 0, it's a positive over a positive, +1. Okay, we're trying to take the limit as x approaches 0. Okay, well, let's see what happens when we approach from the right and the left. And actually, there's a notation that we use for this. The limit as x approaches 0, if you put a little plus there, it means it's coming from the right. And the limit as x approaches 0, and you put a little minus there, that means it's coming from the left. So back to the calculator. So as I'm approaching from the right, the value of the function is 1, 1, 1, 1, 1, 1. It's always 1. Even as I get infinitely close to x equals 0, it's still 1. So what does it look like the limit would be? 1, right? Okay, as I'm approaching from the left, it looks like the value of the function is -1, -1, -1. As I get infinitely close, it's still -1. So in my mind, I'm thinking the limit must be -1. Okay, if you go back to the definition, it says if f of x becomes arbitrarily close to a unique number L as x approaches c from either side, right? If it does not equal the same thing from both sides, there is no limit. So in this case, because these don't agree, that means no limit. I mean, you have to work kind of hard to construct these things so that they don't have a limit, but that's a very typical kind of problem. When you see an absolute value on one side of the fraction and not on the other, that's probably what it's getting at.